Assalamualaikum and good morning everyone. Today we will present about the application of state of matter and chemical equilibrium in pharmacy.
So first and foremost, I would like to explain the state of matter. So matter exists as solid, liquid, and gas. In pharmacy, the state of drug reflects its solubility, stability, onset of action, and route of administration. Most medicine are produced as solid dosage forms because they are stable and easy to handle. For example, paracetamol is a solid tablet. Many drugs are made in solid form because they give accurate dosing, have a longer shelf life, are easy to transport and store, and have low manufacturing costs. Solid drugs go through several steps. First, the drug is formulated as a solid tablet. The body cannot absorb solid particles directly, so the drug must dissolve first before it can give any therapeutic effect. Some solid drugs also have multiple polymorphs. The solid states affect solubility, stability, and flowability. Some powders have poor compressibility, so they need excipients like MCC or starch. The solid states also determine the tablet hardness, flow, stability, and dissolution.
So, what actually happens when you swallow a tablet? First, the tablet breaks apart into smaller pieces. This is called disintegration. Next, those small granules dissolve in your stomach fluid. Once dissolved, the drug in liquid form gets absorbed into the bloodstream. Finally, when it reaches your blood, the medication can start taking effect. That's why the transition from solid to liquid is important. The body can only absorb drugs in liquid form. In pharmacy, some medications come in liquid and gas states. Liquid forms like syrups, oral solutions, injections are absorbed faster because they are already in solution. They're great for children, the elderly, or anyone who can't swallow tablets, like using paracetamol syrup. Gas state medicines, such as asthma inhalers, deliver the drug straight to the lungs. This gives a very fast effect, making them.
Next, I will be talking about the equilibrium constant Kc and the factors that affect it. Kc is the ratio of molar concentrations of product to reactants at equilibrium, each raised to their coefficients. It stays constant only at a specific temperature. When Kc is greater than 1, products are favored. When it's less than 1, reactants are favored. Kc characterizes the position of equilibrium. Pure solids and liquids are not included in the Kc expression. Next, factors affecting Kc. Kc does not change with pressure, concentration, or catalyst. It only changes with temperature. For exothermic reactions, increasing temperature decreases Kc, while for endothermic reactions, increasing temperature increases Kc. A practical example is paracetamol stability. Paracetamol can degrade through hydrolysis or oxidation, and higher temperatures shift the equilibrium toward more degradation, meaning less active drug.
Next, I will continue with Le Chatelier principle. It means that when an equilibrium is disturbed, the system shifts to reduce that disturbance. For concentration, adding reactant shift direction to the right and adding product shift it to the left. For example, when paracetamol absorbs moisture, the moisture acts as reactant and cause more breakdown. Second is temperature. In endothermic reaction, heat acts like a reactant. So adding heat shift it to the right, and in exothermic reaction, adding heat shift it to the left. For pressure, when we increase pressure, it will shift to the side with lower mole of gas and it has no effect in solid or liquid. And lastly, a catalyst only speed up reaction but doesn't shift the position equilibrium.
So now we know what is equilibrium constant and Le Chatelier's principle. But how does this concept can be applied in pharmacy? One of the way is in dosage form development. So let's take a look on a simple drug which is paracetamol. Paracetamol comes in different types of dosage form. One of it is effervescent tablet or soluble tablet. So why does this tablet invented or form? It is to increase the solubility of the tablet. How? This tablet contains acids and bicarbonate which can disrupt the chemical equilibrium when mixed with water. So, when this formulation is mixed with water, it can produce carbon dioxide gas and shift the chemical equilibrium to the right, which means it produces more drugs in dissolved form. Other than that, the solubility of paracetamol tablet can be increased by increasing the pH and the temperature. Paracetamol is weakly acidic and poorly soluble in water. So, increasing the temperature by dissolving in warm water can increase the solubility. Also, in effervescent tablets, It has acids and bicarbonate, which is effervescence agents or alkalinizing agents, which can increase the pH. Hence, the equilibrium will shift more to the right or more to the product side, which is dissolved form. Hence, these are the ways that can increase the formulation towards the dissolved forms, and that's how chemical equilibrium can manipulate the formulation in drug development. That's all from us. Thank you!